उसको डिलीट कर दीजिएगा।
हाँ हाँ फिर से कर लीजिए, ठीक।
Hello students, welcome back in another lecture series of machine learning. Today we will discuss decision tree. Okay, so as you know that decision tree is a supervised machine learning algorithm used for both kinds of tasks, that is classification and prediction or regression. It is structured like a tree where we have internal nodes, branches and leaf nodes. So each internal node represents a decision on an attribute, and each branch represents an outcome of that decision. Each leaf node represents a class label for classification or a numerical value for regression. So therefore decision trees are easy to interpret and widely used in artificial intelligence, okay, in field of finance, medical diagnostics and business analytics. So basically they are structured like a tree, which we will see them in a short while. So structure of a decision tree. So we see that a decision tree has a root node. So in this case the root node over here is the credit score. So this becomes the root node. Okay, that's a starting point of your decision tree. Now everything, okay, this is what? This is an internal node. Then the pathways or the decisions, these are called as branches. And the leaf nodes are the final classified outputs. So these are what? Classified outputs. Okay. So this is an example of decision tree. So now the question comes with that, what is the process of making a decision tree? Okay, so a decision tree is built using recursive splitting approach. Now if you a recursive splitting approach which selects the best feature to split the data at each step. So that means at the root node, this is suppose that it is a root node. So at the root node you have entire data set and you have to take a decision to split the data set into two halves, okay, one on the left and one on the right, to select the best feature to split the data at this point. Now the question is, how do you select that which feature, among which feature of the data set we will do the splitting first. So selecting the best split, that is a feature selection. The most important step in building a decision tree is selecting the best feature to split the data. Now the goal is to maximize the information gain or reduce the impurity. So our goal is to maximize the information gain or to reduce the impurity. Okay. So there are three main criteria. One is Gini impurity, entropy and variance reduction for regression. In this lecture series we are just focusing on how these two calculations are done. Okay. So measuring impurity, The first one, as we have talked about in the previous slide, is known as Gini impurity. So Gini impurity measures how often a randomly chosen element would be misclassified. So the formula is 1 minus summation of P of I. So what is P of I square is the probability of class I. G0, if the value estimates calculates to be 0, that means it's a pure node, all elements belongs to one class. We are talking about impurity, and if the sample is not pure, then it will have some elements of other class also. If Gini index is 0.05, then the maximum impurity, okay, which equals the distribution of the class, has come. For example, if a node has 80% class A and 20% class B, so how do you calculate the Gini index? We already know that we have the percentage over here. We can simply convert the percentage into the ratio, and the ratio gives is that the value, and this can be treated as probability, and that means 80%, 0.8% of the samples belongs to class A and 20% belongs to class B. So now you put them in squares, that 0.64 plus 0.04, that evaluates, and you subtract from 1, the value comes 0.32. So the lower Gini value is preferred when splitting. So for all the, so you will split this because you have got a lower values. If you get a lower value of some other class at this level, so you will choose the lowest value to split. Okay. So this is how the Gini index is actually calculated. Now comes the another technique that is known as entropy gain, and entropy measures the uncertainty in the data set. They are measuring the uncertainty in the data set. So h of x equals to summation of pi log base 2 pi. Okay. So if where the pi is the probability of class I, and if the entropy goes to 0, that means we have got a pure node, no further divisions or splitting is possible or not required. And if the entropy goes to 1, then we have reached the maximum uncertainty. Now for example, we have taken the same example. We have a class A with 80% of the sample at a particular point, and we have a class B with 20% of the sample. So what you do, you again take the probability as 0.8 for class A, and for class B you take 0.2. Now you apply the summation of, okay, P of I multiplied by log 2 base Pi. So that becomes 0.8 log of 2 base 2 0.8 plus 0.2 log of base 2 0.02. Okay, so this evaluates to 0.72. So the information gain is the reduction in entropy after the split. Then you apply, if you want to split that, so you have to calculate the information gain, which is equal to h parent, okay, minus p child multiplied by h child. So that means you will multiply the child, both of the child and the probability, and then you will sum them if there are further classes at this point, and subtract from h parent. The h parent at this point can be assumed as 0.072. Okay, so a feature with a higher information gain is chosen to split. So whichever feature have the highest information gain, that would be process to split. Now, since we have talked about the variance reduction, although it is not in the course, so what we can do, the variance formula is 1 upon n summation of yi, okay, that the actual minus predicted, you take the difference of error and then you square it. So that gives you the variance. So a feature that reduces the variance the most is selected for splitting. So suppose that we have a decision tree. I have taken a small sample just to demonstrate. So let's construct a decision tree using entropy and information gain. The data set, weather and play. The weather data set is given and we have to decide whether we are playing a tennis or no. So this kind of a sample will be the type which you will work with. Okay. So for example, I'm not going to solve it completely, but for example, for playing this data set, so we calculate the edge play. If you remember in the previous slide, there were a total of 5 samples in the data set, and out of which at the 3 instances we played. So instance was play, tennis. So 3 upon 5 multiplied by log 2 base 3 upon 5, log 2 upon 5 and log 2 base 2 upon 5. So it evaluates to 0.97. So we compute entropy for each feature and choose the one with the highest information gain. If the outlook gives the best information gain, it becomes the root node. Okay, so this is how you keep on doing. It's a recursive algorithm. You keep on splitting the nodes unless and until your data set is exhausted. So when the data set is exhausted, so you will have the decision points, decision nodes. So what would be the stopping criteria? Of course, the first one is all samples belonging to the same class. That means no further split is required. No more features are left to split. You have exhausted the data set. Or for a large data set, you can predefine that okay, the splitting has to be proceeded for, let's say, 10 at a depth of 10. Okay, every tree has a depth. So depth of 10, 5, 7, whatever number you want to fix. So if the tree depth reaches a predefined limit, okay, you stop. And this also prevents overfitting. So what are the advantages and disadvantages of a decision tree? Advantages: easy to interpret, handles both numerical and categorical data, requires little data processing, and can model complex interaction between the features. And while disadvantage, it's always prone to overfitting, bias towards the dominant class. That means you are giving a data set that has one class is represented more than other class, so it would be biased. And unstable, the small changes in data can lead to a different tree. Greedy algorithm may not find the global best tree. Okay, so these are the disadvantages. So what do you do if your tree grows to a bigger limit? Okay, so what you do means your tree becomes huge because of large data set. So you can do pruning. Okay, so the way you prune your trees in the garden, you can prune the decision tree. That means removing the unnecessary branches. So pruning helps prevent overfitting by reducing the tree size. Pre-pruning you can do, and you can do the post-pruning. So pre means stop the tree growth early, that you set the maximum depth, or you construct the tree and then remove the unnecessary branches after the tree has been constructed. So another point is that Random forest is a word which you often hear, and it is associated with decision tree. So what a random forest is? A random forest is a collection of multiple decision trees that vote for the final outcome. It reduces the overfitting. It is more accurate than single decision tree. So that means for a from the data set, you divide the data set, let's say in 3 parts, 1, 2 and 3. You construct 3 decision tree, so decision tree 1, decision tree 2 and decision tree 3. Now this will act as a random forest because there are more than one tree. Now a new sample is given, so it is evaluated against decision tree 1, 2 and 3. Now we will have a voting, majority voting. So let's say 2 agree on certain class X, that sample belongs to certain class X. So that means, and one is saying it is belongs to Y, so we will choose X. That's all for the decision tree. Thank you very much.